Good evening, everyone, and sorry for the delay. And welcome for the fifth day of the Faculty Development Program on Future Innovations, Energy and Sustainability. We will now begin technical session 1 of the day. Our resource person for this session is Professor S.P. GonChaudhuri, sir, and it is our privilege to welcome him. A very warm welcome to you, sir. So before we begin, I would like to take a few moments to introduce our distinguished speaker. He is an electrical engineer from Jadavpur University and is internationally recognized in the field of renewable energy. Over the span of his career, he has served multiple prestigious government bodies, including the Government of Tripura, the Government of West Bengal, and the Northeastern Council, contributing significantly to renewable energy development and policy. He served as the director of WBREDA and later as Special Secretary in Energy Department to the Government of West Bengal, where he undertook pioneering work in solar photovoltaic deployment. His projects in the Sundarbans earned global recognition for providing clean energy access to remote communities. He has received numerous national and international honors, including the National Science Academy Award, Green Oscar from the UK, and the Euro Solar Award from Germany for his outstanding contributions towards the sustainable energy access. He introduced the mini-grid concept in India, developed the country's first 2 megawatt grid-connected solar power plant in Asansol, and commissioned India's first floating solar power plant in 2014. His inventions, the microsolar dome, is now a national program benefiting thousands of urban slum dwellers. He currently serves as a visiting professor at IIEST Shibpur and is a fellow of the Institution of Engineers, India. Among his recent recognitions, he was conferred a DSc by the University of Kolkata, awarded Shera Bengali, named Mission Innovation Champion by Canada 2019, received the Asiatic Society Gold Medal in the year 2022 and was honored with the highest civilian award by the Government of Tripura in 2024. We are truly honored to have him with us today. So now with this, I would like to request Sir to take over the session. Thank you.
Sorry to the back. Okay, thank you very much. And at the outset, I must thank NIT Durgapur for inviting me to deliver a lecture on this particularly this training program. Can you see me? Can you listen? Can you hear me?
Yes, sir. Yes, sir. It's
Okay.
visible. Yeah.
Okay, it is visible also. So I'll be talking basically on renewable energy, particularly solar energy, in 3 parts. In the first part, I'll be telling about the development of the energy, that is energy story, little bit, how we are arriving at solar energy, starting from coal, and then the status of solar energy in the country, what are the opportunities, and some case studies in solar energy sector, and then the research areas where solar researches are needed or are going on. So energy is required to do any work. Even when we sleep, we need energy to keep our lung and heart functioning. That is obviously known to everyone, that we need energy to do any work. Maybe it is lighting or agricultural field, maybe in the industry sector, maybe entertainment or transport. Everywhere we need energy. And even when we sleep, in order to keep our lung and heart functioning, we need energy. Now, the global energy challenge. Mankind is facing an enormous challenge, fueling economic growth and improving the living conditions for a growing global population. It is known to every time our energy demand is growing and the global population is also growing. So, per capita consumption of energy is going up and the total energy need is also going up. Energy generation needs to grow substantially by at least a factor of 2 in the next 20 to 30 years. Globally, it is required. These growing energy needs can no longer be made sustainably by conventional means. That you are all aware that coal, diesel, or petrol, and all other gas, all other fossil fuels, non-renewable energy sources are finite in nature. So we can't, meet up the energy need of the future by these energy sources. Moreover, all these sources are polluting in nature. Early source of energy, if we look, maybe 300, 400 years ago, muscle power and animal power, that was the only source of energy. Even now, we are using muscle power and animal power. In rural India, particularly, we find still agricultural activities are going on with animal power. The irrigation is going with muscle power. So muscle power and animal power, these are earlier sources of energy. Now, after that, the oldest source of energy is coal. The story of coal. Coal was one of man's earliest sources of heat and light. The Chinese were known to have used it more than 3,000 years ago. The first recorded discovery of coal was on the Illinois River in 1679. And the earliest recorded commercial mining occurred near Richmond, Virginia in 1748. So at that time, coal was not really used for such a huge purpose like power generation and transport sector. Coal was not used, but at that time, coal was discovered and it was used mainly for heat and light source, as a heat and light source, not for the industry. On April 13, 1750, Dr. Thomas Walker was the first recorded person to discover the use of coal in Kentucky. As you know, the Industrial Revolution played a major role in expanding the use of coal. In 19th century, real use of coal started to power steam engine and later part to generate electricity. In 19th century, you see the railway, you can see entire railway service was based on coal. Now, of course, this coal engine railway, coal engines are phased out. Now, electric engines are there. In between, diesel engine came. But in 19th century, the coal was the main source of energy for the transport in the railway sector. And side by side with the discovery of electricity, in order to generate electricity, maybe 125 years or 200 years ago, maybe 1897, 1890, in that part, we started using of coal for power generation purpose. So this changed the entire demand of the coal in the market, and the demand of coal became huge to generate electricity and also to run the railway engines and also to run the industries. Now, side by side story of oil, the Chinese were again the first to use petroleum as well as the earliest 4th century BC. The earliest known oil wells were drilled in China in 347 AD. Though these wells were not properly designed or properly done, the oil was burned to evaporate brine to produce salt. At that time, salt was produced by evaporating the oil, by using the oil to burn to evaporate brine to produce salt. That was the first use of oil. The modern history of petroleum began in the 19th century with the refining of paraffin from crude oil. In 1846, Baku, I visited Baku, which is the capital of Azerbaijan, started oil exploration by drilling of 21 meters, and that was the first scientific method of drilling, in Baku. Baku is the capital of Azerbaijan now. The kerosene lamp, which was invented in 1854, created the first large-scale demand of petrol. And as you know, at that time, in 1854, there was no electricity. So for lighting purpose, kerosene lantern, at that time, it was very progressive idea, and it was discovered. And the petrol, the kerosene particularly, kerosene was used to light up the, homes and other things through a lantern, through a lantern. And the kerosene lamp invented in 1854 created the first large-scale demand for petroleum. After the petroleum, then the history of petroleum. It came really in the transport sector in a large way, and the diesel engines were also discovered. The diesel started. We started using diesel for generation of electricity, for particularly generation of electricity for various development purposes. Even now, diesel engines are used for captive power plant in many industries, even now. And also the petrol-driven car and diesel-driven car came into the picture in the transport sector. So the diesel and the petrol use was multiplied, and still that is going on in the whole world. Now, till the 1950s, coal and oil were the main source of energy, particularly for electricity generation. In 1954, the Russians set up the first nuclear power plant with the capacity of 5 megawatt. At that time, it was the general opinion that nuclear power would solve the world energy crisis. But later on, due to the Chernobyl and Fukushima accidents, the growth of nuclear power is slowed down. Now, we find a lot of public agitation is there against nuclear power plant, and so the nuclear power growth is not to that extent what we expected. It is very slow. In India, suppose only 5,000 megawatt or 3,500 or 3,800 megawatt of nuclear power plants are there out of 4 lakh megawatt installed capacity. So the nuclear power has not come as we expected when it was discovered, when it came into the picture in 1950s. Pollution has also started with burning of coal and oil, that you are all aware. When you go by the side of a thermal power plant, coal-based thermal power plant, you can see how pollution they are making, the greenhouse gas emission, and that started that impact for the climate change and global warming. The contribution of power sector is about 50%, particularly by burning of coal and oil. So you can see that the picture I have shown how the thermal power plants are polluting the environment. The problem with conventional energy, our current energy system heavily relies on conventional sources like oil, gas, and coal. These you all know 65% dependency. These fossil fuels are finite and their reserves are depleting. They also pollute the environment and are responsible for GHG emissions. The increasing demand for energy put immense pressure on these limited resources. Fossil fuels are limited resource formation. Fossil fuels form over millions of years from biodegradable material under intense heat and pressure, as you know. You can see the use of fossil fuel, how coal use is declining, how oil, gas use is declining, how nuclear power is also declining. But at the same time, if you look at the beyond 2020 picture, you can find wind, solar, and other renewable sources. They are almost 48% of the total power now. By 2050, it will be almost 50%. 62% renewable may be there in many countries by 2050. You can see the picture, the graph which I have shown. Now, the environmental effect of fossil fuels are primarily carbon-based. Their combustion releases a large amount of carbon dioxide, a major greenhouse gas, into the atmosphere. This contributes significantly to air pollution, global warming, and climate change. Now, the solution, what we do, but we need energy, otherwise we can't move ahead. So, in place of the coal and oil or nuclear power, what we can think of. So, the solution is in the 1970s when there was the energy crisis. At that time, the world community, scientific community, came up with the solution that we must go for renewable energy sources. And from 1970 and early part of 1980s, you know, the use of renewable energy, particularly solar energy and wind energy, bioenergy, that started in the whole world. In India also, we started use of solar energy from early part of 1980. The wind energy also from that part. The search for clean energy gained momentum after the 1970s oil crisis. Solar energy is the most obvious choice for a clean energy, abundant and secure power source for the future. It is a key to decoupling economic growth from environmental degradation. It is a very important word I am using, decoupling economic growth from environmental degradation, which is the really in terms of the text, it is the definition of sustainable development. Advantage of solar energy, you can see the solar energy map of India. Everlasting source, the sun is a virtually inexhaustible source of energy. Clean energy, it produces nearly no emissions, causing minimal damage to the environment. Abundant power, the power from the sun intercepted by the earth is about 1.8 into 10 to the power 11 megawatt, far exceeding our current and future energy needs. So it is huge. It is the infinite source of energy. So a final solution will be use of solar energy in the whole world, and the target of the whole UN is to phase out all other energy sources. Only by 2070, solar and other derivatives of solar energy like wind and biomass and other hydropower, with all those things, we have to manage our total energy demand of the whole world. By 2070, net zero target has been fixed. How we harness solar energy? Solar thermal route. Solar energy can be harnessed in two ways. One is solar thermal route, one is solar photovoltaic route. Now, solar thermal technology, these systems convert solar radiation directly into heat. You must have seen a lot of solar water heaters in our country, in many, in Calcutta also there, in Bangalore, in Pune, in Delhi, in many places. You can find the solar water heating system on the roof of the building and also in the hotels and hospitals. A simply designed where a metal surface absorbs sunlight to heat a fluid like water or air, can achieve temperature up to 100 degrees Celsius, ideal for solar water heaters. Medium scale solar thermal system for process heat uses parabolic trough to concentrate sunlight, achieving higher temperature in the range of 200 to 300 degrees Celsius. That is mainly used in the industries. And the central receiver type, you can see the bottom picture, that is central receiver type, suitable for temperature up to which can reach 700 to 800 degrees Celsius temperature, and you can generate really electricity, that is thermal power from this by producing steam and then running the steam engine. So in our country, that opportunities are not there. We don't have so much solar radiation which are available in California desert or Sahara or somewhere. So in those areas, particularly in California, we have seen they have installed solar thermal power generation system which are working fine. Now, the most popular route of solar harnessing solar energy is solar photovoltaic route. The photovoltaic effect was discovered in 1839 by Edmund Becquerel. This effect allows for the direct conversion of sunlight into electricity through a solar photovoltaic cell. How it works: when sunlight photons strikes a semiconductor material, you can see in the picture, like silicon, it creates an electric current in the external circuit. Solar PV cells are heart of a modern solar power system. Once electricity you are generating, then you can use the electricity for any purpose. You can light up the room, you can use a fan, you can use television, you can run industries, you can run traffic system, anything you can do. Street lights, once electricity is there, everything you can do. So this is the basic principle of the photovoltaic. And the point is, in 1839, Edmond Becquerel, a French physicist, he discovered the photovoltaic, but it was not used, it was not applied almost for 20 years. It was not applied. It was just in the book. in the record. But when we first launched the satellite, we needed some energy source in the space. And that was the first occasion when Bell company, they fabricated solar cell for the satellite, and satellites were powered by solar cell by taking advantage of the photovoltaic concept of Edmund Becquerel. Types of solar PV system. There are three types of solar PV system. You can see standalone type we call, grid connected type we call, and hybrid. Those standalone systems are not very, once it was very popular in India, when India, out of 6 lakh villages, 4 lakh villages were not having any electricity. That was in end of the 20th century and beginning of the 21st century. But after 2010, when most of the villages started electrification activities, and by the year 2022, when electrification of villages were completed, then the standalone systems, were not very much required for electrification of villages. But even now, there are some remote villages where standalone solar photovoltaic systems are working. Now, grid-connected system is most popular system. Initially, there was no grid-connected system. It is here we started the Asansol project, as it was mentioned. That was the first grid-connected to megawatt scale project in India. And that is grid-connected. It is connected. Your power from the solar is converted into AC. The DC power you generate from solar energy, and it is converted into AC by an inverter, and it is synchronized with the grid. And the solar power you are generating, it will be pushed into the grid and through a proper metering system, and the meter will show you how much solar energy during daytime you are pushing into the grid. It will be calculated, and if it is a net metering concept, then your home, whatever you are generating power, it will be subtracted from your bill. Otherwise, the large megawatt scale power plants are being installed, and they are pushing power into the grid, and they are signing MOU or PPA, power purchase agreement, with the distribution company. And the large companies are solar, Solar Park and other things. 500 megawatt of Bhadla power plant here in India is 2,200 megawatt. So from there, you can push power into the grid, and you can significantly contribute to the grid power. One more option is their hybrid power plant, that is solar come battery, and say suppose combined with wind or other energy sources. So if you combine 2 or 3 energy sources, that is called a hybrid energy system. And that is also even with a diesel power plant, solar can be hybridized and diesel consumption can be reduced. So that hybrid systems are also available in the country. In many places, the hybrid systems are working to reduce the use of conventional fuel. India's National Solar Mission, it was launched in 20. In India, there is a separate ministry now, though it was earlier Department of Non-Conventional Energy Sources. Now it is the Ministry of Non-Conventional Energy Sources. The National Solar Mission, that concept note was prepared by us. I was also member of that committee, and it was launched in 2010 with a target of 20,000 megawatt of solar power by 2022. Later on, the target was enhanced to 100,000 megawatt by 2022. And as of recently, over 120,000 megawatt have been installed in the country, with more power plants in the pipeline. The new target fixed up by the Honorable Prime Minister, that by 2030, we should have about 300,000 megawatt of solar power in the total energy basket. This mission has significantly brought down the cost of solar energy in India. Initially, the solar energy cost was very high, but now the solar power cost is very low and very competitive. It is less than the thermal power plant cost now. It is only 2 rupees 80 paisa to 3 rupees. Honorable Prime Minister of India has given a commitment in Glasgow Conference of Parties COP that India will have 500 gigawatt of non-fossil power generation the capacity by the year 2030 to reduce the emission level as per our commitment. So we are going towards that target. The challenge of solar power intermittency is the main challenge. The main challenge of solar PV based power is its intermittency. Solar panels only generate electricity when the sun is shining. That is known to each of us. This creates a mismatch between energy generation and demand. Especially during evening, our demand is very high. Nighttime demand is also high. And daytime peak is also there. At that time, solar can definitely cater the daytime peak load, but in cloudy days again there is some problem. So solution is obviously the obvious solution is energy storage. So I'll be speaking on energy storage a little bit now, which is very important. A lot of activities are going on in various NITs, IITs, and various universities. Throughout the world, research activities are going on energy storage, because the solar energy can solve the energy crisis only there if there is proper storage of solar energy to cater the nighttime load and the monsoon period. India's renewable energy progress, you can see the total installed capacity is now almost 251 gigawatt, including solar, wind, and you can see the solar. The wind and solar is about 130, 1,30,000 megawatt, and wind is about 50. Hydro is there, and wind power is 54,000 megawatt. So basically, the hydro, solar, and wind are the most important renewable energy sources. Other energy sources are very small, but we have some biomass-based power plant and other type of renewable energy power plant. Now, let us discuss something about energy storage. Energy storage is crucial for a stable and reliable power grid based on intermittent renewable energy, renewable like solar and wind. It acts as a reservoir, storing excess energy when generation is high and releasing it when demand is high or generation is low. This ensures a continuous and reliable power supply, 24/7 power supply. So that is the main objective, that we should supply power for 24/7 with proper mix of storage and direct use of solar and wind. Battery system, as you know, that is the most common and popular and the cheapest energy storage up to now. A battery is an electrochemical device that converts chemical energy into electrical energy. They are most common and sensitive components for storing energy in a solar PV system, often accounted for 40% of the total cost. But the problem is now solar PV cost has come down. Earlier it was very high. Now it has come down to say 12 rupees or 13 rupees per watt. But the battery cost is more than the PV cost, and which is about 40% of the total system cost. They provide a reliable backup power source. They provide a reliable backup power source. And there are many villages where solar power plants are available with a proper battery backup system. In Sundarban, still many power plants are working with lead acid batteries, maybe silk batteries or other things with solar photovoltaic power plant as a decentralized solar power plant. I will show you some picture of that in the case study. So battery is a good option for storage of the solar energy, but it is expensive. Now, types of batteries for solar storage: lead acid batteries you have heard about, nickel cadmium batteries known for their long life. Lead acid battery has a limited life, but nickel cadmium known for their long life and durability, but contain toxic material. Lithium-ion batteries are most common. Now the research works are continuously going on, and it's now cost is also coming down, and it has a longer lifespan, and its cost is decreasing. They are coming up in a big way. Lithium-ion batteries are used in computers and all other areas, and even in solar power plant, lithium-ion batteries are being used now. Other emerging batteries like vanadium redox flow batteries and sodium-ion batteries are in the pipeline. A lot of research activities are going on, and in future, the large-scale storage may be done through these vanadium redox flow batteries and sodium-ion batteries. Sodium-ion battery cost will be very, very low. It will be very, very cheap. Other forms of energy storage: pump hydro is a wonderful idea to store solar energy for the nighttime or for the cloudy days. The most common form of large-scale solar energy is pump hydro power scheme. During off-peak, there is a pump which there are two reservoirs, lower reservoir and upper reservoir. From the lower reservoir, water is pumped to the upper reservoir during off-peak period, and during peak period, hydro turbine is rotated from the hydropower. It works like hydropower at that time. For pumping of water, the conventional power from the coal-based thermal power plant are taken. Now, in case we can change it for pumping of water, if we can take it from solar energy during daytime, and if we can pump water during daytime, then you see the night time we can use that water, and it's a good option for storage. So how it uses excess electricity to pump water from a lower reservoir to an upper one. When electricity is needed, the water is released back down, spinning a turbine to generate power. Solar pump storage is a very promising and unique storage technology, which we have tried. I'll show you a case study. In Manipur, the first solar pump storage scheme has been installed, where solar PV power plant is pumping water to the upper reservoir, and there is a small turbine which is generating power during night time also from the solar power. Mechanical, gravitational, and hydrogen storage. Private storage, you are all aware, private storage is spun to high speed using excess electricity, storing energy kinetically. The energy is released by using the spinning force of to drive a generator. Gravity storage uses excess energy to lift a heavy weight like a block or concrete. When power is needed, the weight is lowered and the gravitational energy is converted back into electricity. Compressed air storage, these are all under research, but these are all options. Air is compressed and stored in an underground cavern to generate electricity. The compressed air is released to drive a turbine. Hydrogen storage, storing solar power in hydrogen through electrolysis of seawater, is also a very popular concept. And in the hydrogen mission of the country, the hydrogen storage and production of hydrogen are all objective, and a lot of research activities are going on. Some pilot scale applications are also there, have also been developed. We have seen the use of hydrogen, the use of solar energy, through hydrogen route. But for production of hydrogen also, we are using solar energy for electrolysis of water. Though it is expensive, but the fuel cell we are using where you need to electrolyze the water to get hydrogen. So we can use the solar energy for electrolysis, and later on through fuel cell during night time or during the cloudy days, we can use that solar energy from the through the fuel cell. Electrical and magnetic storage, supercapacitors, these are all under research activities, store energy in an electric field. They can charge and discharge much faster than batteries, but store less energy for their size. It is ideal for application needing quick bursts of power. Superconducting magnetic energy storage stores energy in the magnetic field created by the flow of direct current in a cryogenically cooled superconducting coil, offers very high efficiency and rapid response, but the technology is very, very expensive, and the research works are going on. It may take 10 years, 15 years time to come. Some decentralized option of renewable energy, I'm just showing you. We can use this type of DRE we are using in the country, like solar atachaktis are common now, solar milk chiller, solar cooker, though it is thermal, but solar cookers in Brahmakumari Ashram, through a solar cooker, they are producing their meal for about 2,000 people daily. Solar cold storage, a lot of this is a very potential area for storing of potato in remote areas, where electricity is very erratic. There we can use solar cold storage scheme. There are some solar already, some demonstration cold storage scheme has been installed in the country, and people are keeping their potatoes and other perishable goods in the cold storage. Solar power loom, solar standalone power plant, you can see still under use. Solar refrigerator, solar powered e-rickshaws. That is the future of e-rickshaw, because electricity cost is coming up, and the cost of charging of batteries of e-rickshaw is very high. so they can charge their batteries on board with a solar panel, and they can run the rickshaws, which will be very cheap. Solar power boats are also coming. Some demonstration boats are there in West Bengal and Kerala, but other states are also trying for that. So these are called all DRE program that is run by Government of India, MNRE, and throughout the country, this type of application of solar energy. These are not really grid connected system, but in DRE system also there is an opportunity to use solar energy in order to remove the diesel power. Mainly they are diesel. The atta factories are running with diesel. The solar cold storage, solar power looms are in off-grid areas. Diesel power plant, diesels are being used. So this, in order to phase out diesel, boat, thousands of boats are working with a diesel engine. You have seen that, and a lot of pollution is there. In Sundarban itself, there are 10,000 boats with diesel power plant, operating with diesel power plant and polluting the entire environment of the Sundarbans. So in future, maybe in 5-7 years time, all these DRE systems will be popular, we are expecting, and there will be a lot of opportunity for employment generation also, and a lot of generation in the economic growth will be there in the remote areas. So this is also a good option for use of solar energy. This case study one, solar power, India solar power is the journey begins. The country's first megawatt solar power plant, as I have mentioned, it was installed. This is the picture of that Asansol, West Bengal, in 2009. It was designed by me, and it was installed first megawatt scale solar power plant, grid connected in the country. High initial cost, at that time cost was 17 rupees per unit of solar power, and it was really it was a model for the National Solar Mission project. Now, with the launch of National Solar Mission project, drastic driven policy, the India has been massive growth in solar installation and drastic cost reduction happened. Today, the cost has plumbed to as low as 3 rupees per unit, making solar one of the cheapest source of new power generation. Case study 2, innovation in general and storage. Floating solar power plant. As you know, India has some problem with the valuable land space. India is pioneering the floating solar plant. The first the floating solar power plant was installed. That was also installed by me in Kolkata in 2014 with a capacity of only 10 kilowatt peak, with larger power plants like 25 megawatt and other thing the NTPC has done in Andhra Pradesh. And the new concept in the solar power plant, floating solar power plant, is a bamboo base. IIT Bhubaneswar, they are also doing some research work. NBIRT Tripura, they have done research work, and they have installed a 5 kilowatt bamboo base, that is the structure. Floating structure is bamboo with solar power plant, solar PV power plant, to reduce the cost of the installation. IIT Bhubaneswar and IIT Palakkad, they are also trying to put up a large, maybe 200 kilowatt capacity, so floating solar power plant, bamboo-based solar power plant in a lake. Case study 3, integrated solar and energy storage. As I have mentioned, in Manipur, this is a pump storage scheme. Solar hybrid pump storage power plant in Hengbang, Manipur, is a leading example of combining solar generation and storage, provide power for 24/7. The power generated by the power plant serves about 50 households in the village of Hengbang. The system can store intermittent solar power into pump power through pump storage system. Case study 4, decentralized energy system, which is, you can see a unique system, the Ghoramara Island of Sundarban, where there are about 5,000 people. You will be surprised to note all the 5,000 people, that island is totally disconnected from the mainland, and power will never go to that island. That 5,000 people were using kerosene. Now all the 5,000 people are either using electricity from solar power plant, or they are using their own solar home lighting system. That is the only island in the whole world which is 100% on solar energy. So this system, you can see the system installed in the year 2023 in November, and still working properly. So this is a unique example of India solar energy off-grid solar program, and serving the off-grid communities. The system installed at Ghoramara provides power to 650 houses, serving about 3,000 residents, and balance 2,000 residents. They are using rooftop solar, that is home lighting system. Additional power is also provided to you see the change of the island. Entire island, all the commercial shops and other things have grown up now with solar power. The island is fully lit by solar street lights. There are now 10, 12 totos moving in the village road, and they charge their battery for the solar power plant. The entire village is clean village, and entire village is solar village. Solar Ghoramara. It was Ghoramara. It is the name of the village is Ghoramara. Now we call the Ghoramara village as Solar Ghoramara Island. Case study 5, electrifying Baripeda village of Keonjhar, Odisha. Same type of concept, in Odisha, in Keonjhar district, there are 3 tribal villages where electricity may not go because grid line is 20 kilometers apart from the tribal village, remote tribal village. The road is also bad. So we have installed a similar 60 kilowatt solar PV power plant standalone under the Department of Science and Technology, Government of India program. The IIT Bhubaneswar, they have really set up the plant, and we have helped them by giving the design concept and other thing. This is another example of electrifying the whole village. That village, Baripeda village population is 400, and all the 400 people are getting electricity. But there, one important option is there are 3 energy vectors. Solar power plant is the main energy source, and in case there is no solar power, no battery backup, then they have a biomass power plant, 10 kilowatt capacity, biogas power plant. All these 3 energy vectors have been synchronized, and they run in case of solar failure. That hybridized power plant, that is the biomass power plant runs, or the biogas power plants run. This is one of the unique concept. The power plant is running for last 1.5 years, and people are very satisfied. They pay 100 rupees per month and using electricity for their lighting purpose, for television, and some of them has got also freezer refrigerator. Case study 6, access to 24/7 running water from solar. In many areas of India, no drinking water is available because purification system needs, electricity. So the solar water purification system has been developed through research funded by Government of India, IIEST, and a number of villages have been now provided with clean drinking water with solar pump and solar water filtering system. People, particularly the tribal people, they are getting water, and many solar pump is a very common and popular technology. Solar pumps, under Prime Minister program, solar pumps have been about 1 million solar pumps are working in the country now. Not now, about 7 lakh solar pumps are working. That is called PM Kusum scheme. With that, 3 lakh more solar pumps will be installed in the country by the end of 2026. So that type of solar pump, along with the solar water purification system, is combined with that, and people are getting pure drinking water in the villages through this system. So solar energy has another application in the supply of drinking water. The future research and development, large-scale storage, as I have already mentioned, that large-scale storage is required to really deploy the solar energy at a very large scale. Otherwise, the target, which has been kept as 2070 net zero target, may not be achieved. So we have to have, develop the large-scale storage system. So a lot of research activities throughout the world are going on. So you are all teachers, you are all researchers. So you can think over about the research project, which is a priority area of Government of India in the solar energy storage. You can think over about some research project, and which can be submitted to either Department of Science and Technology or Ministry of New and Renewable Energy, and sometimes even Department of Biotechnology, they support this type of scheme. Advanced PV technology, creating larger, more efficient solar panel, the 1,000 watt plus, this TopCon technology is on now. We are getting about 600 or 650 kilowatt per module. Now new technologies are coming, heterogeneous solar cell, HDR. These are coming with that 700 watt, 750 watt solar modules. Panels are also available. Though it is not in the market, common in the market now, but these are on the demonstration page now, and the target is to produce one solar panel with 1,000 watt and 23 to 24% efficiency. These are all silicon solar cell, the silicon either monocrystal or polycrystal, but exploring new material like perovskites is also a very important area to produce very cheap and long life solar cell, but still under experimentation. Perovskite solar cells could be a good idea. Grid integration, working towards an international solar grid. Suppose you draw a grid from India to US, the international grid, through different countries, say 30 countries or 37 countries. When in India there is daytime, you generate solar power and export solar power to the US, because US at that time it will be night. Or the in-between countries may get also support from that. And in US, if you generate power during their daytime, you may get up to India as solar power, because at that time our night will be there. So this concept under ISA, International Solar Alliance, which is headquartered at New Delhi, and about 47 countries are partner countries. They are all doing this particular, working on this particular project, International Solar Grid. It is expected by the year 2047, that is the India 100 years of its independence of India, the International Solar Grid may be a reality, and at that time this type of power export import will be there from US to India or India to US and other countries in between. So that type of thing could be there. Circular economy, focusing on the recycling of used solar panels and batteries. That is also important, because the huge number of solar panels will be defunct after 25 years or 30 years. So what we will do that, and batteries will be there from the electric vehicle particularly. So how it can be reused, how it can be recycled. So research activities are going on throughout the world on that also. That is also one important area where you can think about research activities. New applications, solar highways for EV charging in the on the road. PV-based roads can be constructed. Chinese or French people, they have already constructed PV-based road. While cars are moving over the road, such road, they are getting automatic charge. Or even you can have a very large solar power plant on the highway, where the people can, the electric vehicle can move and can wait for 10 minutes for fast charging, and 10-15 minutes they can charge their vehicle, take a cup of tea and charge their vehicles. Then again they can go for 400 or 500 kilometers. So we can have 400 after 400 or 500 kilometers, we can have refueling station. So that concept is also very much in the pipeline, and research activities are going on. The Chinese are also working on an artificial moon in order to remove the street light concept. That is also one area. Some people through satellite, they are trying to give solar power in the daytime, or whatever you give your coordinate to that company, they will supply you solar power in the night in the location which you are giving. So something like that, research works are going on and maybe commercialized within next 5 years time. The enhanced forecasting, the minute-to-minute accurate forecast about generation from solar power plant for grid stability is also one research area. US is doing a lot of research. European countries are also doing a lot of research. Japan is doing a lot of research on wireless solar power from the space satellite to receiver station in the Earth. They have in fact already done 1 kilowatt power plant. They are getting 1 kilowatt power. They are expecting that in future that type of concept, because in the space there is no cloud or there is no night. So all the time, 24 hours, you are getting power, which can be sent to the Earth in the receiving station, and then it can be transmitted throughout the country. So all these ideas are coming up. Research activities are going on throughout the world, and scientists like you, researchers like you, they are doing research activities. In India, also a lot of research activities are going on in the solar energy sector. I hope really in future the solar energy, wind energy, and the hydropower, maybe to a little bit extent, nuclear power will be backup. So that will be nuclear power is clean power, very clean, not 100%, but very clean power, not like coal or oil, so or gas. So with all these, combination integration, the net zero target of 2070 can be achieved throughout the world, and we can have a livable world. So my conclusion is a sustainable future. To secure our prosperity for the 21st century, we must decouple economic growth from the consumption of scarce resources. That is very important. We have to do that in order to secure our prosperity for the 21st century, and in order to have a sustainable development. Transforming our energy system is absolutely essential to prevent a constant rise in greenhouse gas emission. That we have to stop. If we have 4 degree or 5 degree temperature rise in the atmosphere, in the global energy, in the global warming, the climate will drastically change. Already it has started changing. Already the temperature rise is more than 1.5 degrees Celsius in comparison to the industrial revolution time. It is about 2 degrees Celsius more now, and the seawater rising. Seawater is rising, and the dangerous situations have been observed in Sundarbans, in Bangladesh, and other areas. So we have to protect our Mother Earth from that by using the sustainable energy sources like solar, wind, and biomass, and the hydropower source. And we must phase out coal, oil, and natural gas. So that should be our target. Solar energy paired with sustainable and reliable storage solution provide a clean path towards a clean, green, and sustainable world for the future generation. And we must keep a world, the green world for the future generation, so that they can also keep a green, better world for the next generation. That should be our target. And with all this thing, I think I conclude my deliberation, and I will be keen to take your question if you have any. But finally, thank you all for patient hearing, and let us keep a clean and green world for the future generation. Any question you can ask me. Thank you.
Thank you very much, sir, for sharing your remarkable journey and valuable insights on sustainable energy initiatives. So participants, now we have opened the floor for questions. So please proceed with your questionnaire and be quick.
Hello.
Yes.
Yeah. Good evening, sir. Very nice talk, sir. Sir, I have one doubt actually, not like question. Like you have mentioned, decentralized the energy, and means like use of more and more solar panels. But if we think about the sustainability, then the e-wastage, how we will means simultaneously we will produce lot of e-waste.
I have mentioned that in my presentation. I have told about that yes, that is a problem, but that problem is going to come only after 25, 30 years. So, and by that time, recycling of, this electronic material like solar panels and batteries and other things will definitely, there will be, already Japanese, they have come up with the solution, some solution to reuse the solar panel waste. and reuse the battery. So I hope through research and development activities, within next 10 to 15 years, there will be a commercial, e-waste utilization system developing the world.
Okay. Thank you, sir.
Any other question? Be frank, no problem. You can ask me any question, because there will be a test also where we'll be giving some questions on this topic. If you have any doubt, you can ask me.
Participants, if you have any question, please be quick. Sir, I think there is no questions from the participant end. So can we stop the question and answer session?
I think there is no question.
Yes, sir. So now we'll proceed for the screenshots. So I will request from all the participants to please switch on your camera. And sir, if possible, the screen sharing mode, if can be.
Just wait for a minute.
Yes, sir.
They will take a photo, screenshot. Yeah. Is that all right?
Sir, now it's fine.
It's fine, sir. Thank you. Thank you.
Okay. So thank you very much. Thank you all. Namaste. Can I leave now?
Yes,
Yes,
sir.
sir. You can leave now.
Okay.
Thank you, sir. Thank you.
Okay.
Yes, participants. So we have concluded the technical session 1. For technical session 2, we'll start that from 7:30, sharp 7:30. So please remain present. Thank you.